Hi, my name's Peter Fan, and this is my presentation on the energy chapter of the text Sustainability Principles and Practice by Margaret Robertson. So, every living thing uses energy. We humans also use energy. The most popular form of energy that we use is called fossil fuels. Energy comes from resources, so some are renewable and some are not. Fossil fuels are an example of a non-renewable resource. It means that they're not going to replenish. Unlike sun and wind, fossil fuels regenerate over geologic timescales. It's much longer than what's relevant for us, and so for our purposes, once they're used up, they're gone for good. So what are fossil fuels and how do we get them? Fossil fuels are naturally found in three forms. You've got oil, natural gas, and coal. Oil is also called petroleum, and it's so prevalent in today's world that to find a non-metal object that doesn't have petroleum as part of it is surprising. Oils, grease, paints, things that are less obvious, such as vanilla flavoring, shampoo, shoes, glue, even fertilizer, they all have petroleum. Fossil fuels are used for just about everything, but one of the biggest things is in agriculture. Around the world, agriculture is one of the biggest things using fossil fuels. So fossil fuels are hydrocarbons. It means they're made out of mostly hydrogen and carbon. They come from fossilized marine plankton and terrestrial plant material. These ancient resources formed 10 to hundreds of millions of years ago, and it would take similar time scales to do that again. It's why they're called non-renewable. We gather these resources in raw form through drilling and fracking. The collection and processing of fossil fuels for everyday use creates many waste byproducts. This cycle of energy consumption is not sustainable, and we can't keep going this way. There are two main issues with sustainability. The first is the large ecological footprint by destroying natural ecosystems, and that fossil fuels have reached their peak reserves, meaning there's less left over in storage than in the years before. So many industries around the world have shifted to alternative energy solutions. Either they get more efficient, they're building their buildings more green, they're minimizing their air and emission pollution, or they're transitioning away from fossil fuels altogether. Much work being done worldwide to deal with fossil fuel reserves going low. We got research into solar panels and wind turbines as alternate energy sites. We have transition towards decentralized smart grids. And we do a thing called net metering, where if you produce your own energy, you can actually give it back to the grid and then at the end be able to be paid for it. So you can actually profit from energy creation and collection. Hydroelectric power is a reliable source of renewable energy. We've got dams. Here I drew water wheels and tidal flows, and they're zero emission. We have geothermal energy, which is like natural radiation, heat, and pressure from within the earth that we can use to generate energy. A lot of industries are using something called cogeneration, where they take their exhaust heat and waste and reuse it within the facility, and this doesn't create any more emissions because it was already waste to begin with. They're just recycling the heat energy back again through the machines. The companies end up lowering their energy costs and reducing the environmental impact. So biogas repurposing the heat from methane and sewage from waste treatment plants and livestock farms can be also reused as a fuel source with cheaper production costs than actually getting their energy from external sites. So let's move on to transportation. In popular media, transitioning away from fossil fuel-based transportation is probably the most popular nowadays. Transportation is the biggest user of oil and accounts for a significant share of greenhouse emissions. So we've got alternatives, but they each have their own costs and drawbacks. You can use natural gas, but natural gas is still a fossil fuel. It's just 25% more efficient. So natural gas is classified as a transition fuel. We have biofuel, which is sugarcane, grain, and other plant-based materials being used, processed and used as a partial substitute for petroleum. The biggest setback here is that you get minimal energy gains. The energy transfer from raw materials to fuel is basically 1-to-1, so it's not that much worth it or better. Stored in complex containers, we have hydrogen fuel cells. So hydrogen doesn't contain energy, but when you take oxygen and hydrogen and combine them together, they create water with producing electricity in the process. So with fuel cell technology, we can harness the energy and put it into our vehicles. The biggest setback is that fuel cells are very difficult to transport and store. Liquid hydrogen must be cooled to minus 423 degrees Fahrenheit and need really thick walls and whatnot to use. The infrastructure is just not there yet. We can remove the combustion step from transportation altogether and utilize battery-powered electric vehicles. So the cost per mile for a car to run on electricity is several times less than that of a gas-powered car. The only trouble with electric vehicles is that you charge them using traditional fossil fuel plants. You're not actually eliminating your emissions, you're just transferring it, so now the plant is doing the emissions, and it would actually potentially be worse in the long run. So for electric vehicles to truly thrive, we have to increase battery technology and alternative energy technology. Moving on to buildings. So buildings are a significant sector of all energy consumption. And while new constructions are able to adopt green methods, the truth is that the ratio between old to new buildings is about 50-to-1. So we have to find out creative ways to lower emissions and fossil fuel use on existing buildings. The transition from fossil fuels to alternative processes, we have to have a way to measure that. And we use something called an energy utilization index. It's similar to like how vehicles use miles per gallon. So building owners have to consider lighting, heating, cooling, ventilation, and human behaviors as possible problems to reduce the EUI. The easiest thing is to close air, steam, water leaks, cracked windows, calibrating thermostats. Those are the easiest types of things to handle. The next challenge is to change occupant behaviors. The biggest one is to reduce phantom load, which means just like turning off your appliances instead of putting them on standby mode. But the largest cost of energy and resources is the heating, cooling, and lighting system. These are called the capital projects, and they take long-term investments and cost the most. We can hire energy service companies to assist building owners in reducing their EUI, and the savings that the owner would have saved, a portion of that would be what these energy companies charge. So then in the end, everyone would profit. So how do we get away from fossil fuels? We're at the beginning of a transition period away from fossil fuels already, but even with political and cultural forces working together on this alternative energy push, analysts project that it'll still be a long time before we completely get off of fossil fuels. So in the meantime, we need to do more research and development, and especially we want to increase the energy service, which means the amount of useful work done with our fuel. We want to make things more efficient. So our world is an interconnected world of water, energy, and food. An abundance of one will allow you an abundance of the other, but a shortage of one will cause shortages in the other. As populations rise, we need educated people and creative solutions. So fossil fuels have gotten us through a lot, the Industrial Revolution, the Information Revolution, but moving forward into the future, we need to start thinking about what we're going to do when the fossil fuels are gone. The problem is that fossil fuels have more energy density than anything else that we know, which means that a world that doesn't have fossil fuels anymore is a world that is not going to have as much energy. Even if all of the others, they're never going to match fossil fuels. We need to lower our demand for energy and learn how to live more sustainably. Thank you for watching my presentation on energy, and I hope you have a good summer.